Alright, so in this problem I have 2 to the power of x minus 2 to the power of y is equal to 120. So at first glance, we can already tell that 2 to the power of x is greater than 2 to the power of y, because 2 to the power of x minus 2 to the power of y is a positive number, meaning x is greater than y, because both of these have the same basis. So because we know that x is greater than y, we can say that x is equal to y plus some variable k. So now I'm going to replace x with y plus k. So now I have 2 to the power of y plus k minus 2 to the power of y is equal to 120. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of y plus k, that's going to equal 2 to the power of y times 2 to the power of k minus 2 to the power of y is equal to 120. Now if I factor out 2 to the power of y, I get 2 to the power of y times 2 to the power of k minus 1 is equal to 120. Now 120, this is the same thing as 8 times 15. And notice how we have an even number, 2 to the power of any number is even, times an odd number, because an even number minus 1 is going to be odd, is equal to an even number times an odd number, meaning these two even numbers are equal to each other and these two odd numbers are equal to each other. So we have 2 to the power of y is equal to 8, and 2 to the power of k minus 1 is equal to 15. So let's first start off by solving 2 to the power of y equals 8. Well, we obviously know that y is equal to 3, because 2 to the power of 3 is equal to 8. Now for 2 to the power of, this is actually 2 to the power of k minus 1. Negative 1 is not part of the exponent. So I'm going to start off by adding 1 on both sides. So I get 2 to the power of k is equal to 16, meaning k is equal to 4. Now remember how we set x equals y plus k, and k is 4, y is 3, meaning x is 7. So now to check, my original equation was 2 to the power of x minus 2 to the power of y equals 120. So we know that x is 7 and y is 3. 2 to the power of 7 is 128, minus 2 to the power of 3 is 8. So I get 120 is equal to 120. Alright, so in this problem, I have x to the power of 6 is equal to x minus 1 to the power of 6. So I'm going to first start by subtracting x minus 1 to the power of 6 on both sides. So then these two cancel out, and now I have x to the power of 6 minus x minus 1 to the power of 6 is equal to 0. Now x to the power of 6 is the same thing as x to the power of 3 to the power of 2, and x minus 1 to the power of 6 is the same thing as x minus 1 to the power of 3 to the power of 2. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is going to equal x to the power of 3 plus x minus 1 to the power of 3 times x to the power of 3 minus x minus 1 to the power of 3, which is equal to 0. Now if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So this is going to equal k plus k minus 1 times k squared minus k times k minus 1 plus k minus 1 squared. Sorry, this is actually supposed to be x, but yeah. So this simplifies to 2x minus 1 times x squared minus x plus 1 times 3x squared minus 3x plus 1 is equal to 0. Because we also added in, remember, we also have x to the power of 3 plus x minus 1 to the power of 3. So now this gives me three different equations. I have 2x minus 1 is equal to 0, meaning x is equal to 1/2. I have x squared minus x plus 1 is equal to 0. And I have 3x squared minus 3x plus 1 is equal to 0. So for x squared minus x plus 1 equals 0, we have x is equal to 1 plus or minus the square root of 3i over 2. And finally, for this, we have 3 plus or minus the square root of 3i over 6. Alright, so in this problem, I have 11 to the power of 9x plus 11 is equal to 9 to the power of 11. So to solve this problem, I'm going to first start by taking the log on both sides. So I have log 11 to the power of 9x plus 11 is equal to log 9 to the power of 11. Now if I have something in the form log a to the power of b, I can move b to the front. So this is the same thing as b times log a. So log 11 to the power of 9x plus 11, I can move 9x plus 11 to the front. And log 9 to the power of 11, I can move 11 to the front. So now I have 9x plus 11 times log 11 is equal to 11 times log 9. Now I'm going to divide both sides by log 11. So then these two cancel out, and now I have 9x plus 11 is equal to 11 times log 9 over log 11. Now, log 9 is equal to 0.9542, and log 11 is equal to 414. So now I have 9x plus 11 is equal to 11 times 0.9542 over 1.0414. And this is the same thing as 11 times 0.9163, which is equal to 10.0789. So now I'm going to subtract 11 on both sides. So I get 9x is equal to negative 0.9211. Now if I divide both sides by 9, I get x is equal to negative 0.1023. So this is my answer to this problem.